go to your unions and intersection page. So a union is when one thing is true or the other thing is true or both are true. So you're just looking at both examples and seeing what all could be in either one. For example, my union of soccer with tennis. So that means who all has this true? Well, Alex, Hunter, Casey, and Drew. So Alex, Hunter, Casey, and Drew. Okay, and then where's this true? Well, Jade, Casey, and Drew. So I already have Casey and Drew, so Jade also. So for the union now, I look at all of it together. So Alex, Hunter, Casey, Drew, or Jade play either soccer or tennis. So that is the union between soccer and tennis, is all of those people. Okay? The intersection is when only both things are true. So soccer intersection with tennis is, well, who has both of these things true? Well, soccer is Alex, Hunter, Casey, and Drew. Tennis is Casey, Drew, and Jade. The only one that has both is Casey and Drew. So Casey and Drew. Okay, so that's the difference between unions and intersections. So let's go ahead and apply that to our geometry. So please, first thing what you're going to do is put your points and label them. The picture we provided you accidentally, we didn't have points. So put yours exactly where mine are. Pause the video, do that real quick. All right, and then once you did that, let's go ahead and talk about this. Union of ray AB and BC. Well, ray BC starts here, continues on. Ray AB starts here, continues on. Well, together they start at A, continue all the way on. So AC continuing on. Does it continue on in the A direction? It does not, because we started at A, we don't have the arrow going the other way there. Okay? The intersection of ray AB and ray BC, well, which do these two have in common? All right, so ray AC continues on like that, right? All of that. Ray BC starts here and continues on like that. So which is true for both of them? Both have ray BC continue on, but they don't both have starting at A going to be. So ray BC. All right, union of segment AB and BC. Well, AB and BC together creates AC. So we have segment AC. Intersection of AB and BC. Well, what do AB and BC have in common? For intersection, you're always asking what do they have in common. So they both just have point B in common. So my answer is point B. Union of ray BA, so start at B, continue on in this way. Oh, not union. Intersection of ray BA, continue on here, and ray BC. Intersection, again, I'm asking what do they have in common? Well, between these two, what do they have in common? It's just point B again. All right, and then the union, now we're adding them together with union. So adding together ray BA and ray BC, well, I start here, go in this direction for one. Then I start here and go in this direction for the other. So now, when I'm adding them together, I'm going in both directions indefinitely. So I'm creating that whole line going in both directions forever. All right, union of ray BD and BE. So what is this whole thing including? Well, I just created an angle. So I created angle DBE when I'm adding those two together. All right, now intersection of angle ABE, so ABE, so this whole thing, with DBC, DBC, that whole thing. Well, what do they both have? They both have this thing in the middle, that angle right here. So that is angle DBE. Right? We started with this whole thing, then we had this whole thing. Oh, they both have this piece of that pie, that angle. Union of angle ABE, so ABE right here, with DBE, DBE. Well, when I add the two together, I still just have ABE, right? So I took ABE and added the smaller section to it that it already had. So it's still just angle ABE. And then last one, woohoo, angle ABD. That's this piece. Union, so added together with DBE, that piece. So we're adding this piece and that piece. So together we have ABE. So angle ABE. And that's it.